Dear friends, this is my lecture related to numerical problems on Poisson geometric and negative binomial distributions. So this is related to Poisson distribution. Let X follows Poisson with parameter lambda. Then its probability mass function is given by probability that x is equal to x equal to e raised to minus lambda, lambda raised to x by x factorial, or x is equal to 0, 1, 2, etc. The peculiarity of this distribution is mean and variance both are equal to lambda. And note that Poisson distribution is a limiting case of binomial distribution when n is large and p is very small. That is, when n tends to infinity and p tends to 0, and if we consider n into p equal to lambda. Now let us consider the first problem. The past experience shows that on an average there are 2 traffic accidents on a particular road every week. What is the probability that first bit no accident during a randomly selected week, and second bit 3 accidents during a randomly selected week? Now for the solution, let us consider let x denotes number of accidents on a particular road per week. So given lambda is equal to 2, and here x follows Poisson distribution with parameter 2, and therefore its PMF is given by probability that x is equal to x equal to e raised to minus 2, 2 raised to x by x factorial for x is equal to 0, 1, 2, etc. Now for the first bit, the probability that there is no accident during a randomly selected week, that is equal to probability that x is equal to 0 and is given to be e raised to minus 2, 2 raised to 0 divided by 0 factorial, and the final simplification is 0.1353. Second bit, the probability that there are 3 accidents during a randomly selected week, that is equal to probability that x is equal to 3 by substituting lambda is equal to 2 and x is equal to 3 in PMF of Poisson distribution, and by simplification it gives us the final probability 0.1804. Let us consider second example based on the limiting case of binomial distribution. So it is given that 2% of the screws manufactured by a company are defective. Use Poisson distribution to find probability that a packet of 100 screws contains first bit no defective screw, second bit one defective screw, and third bit 2 or more defective screw. For solution, let us consider x as number of defective screws in a packet of 100. So given that the probability of defective screw, that is p equal to 2%, that is 0.02, and the sample size n is equal to 100. So here x follows binomial with 100 and 0.02. As n is equal to 100 is large and p equal to 0.02 is small, consider lambda equal to n into p, that is 100 into 0.02, that is equal to 2. So here from the theory of limiting case, x follows Poisson distribution with parameter lambda is equal to 2. Therefore its PMF is given by this equation. For first bit, probability that there is no defective screw equal to probability that x is equal to 0, and as the previous case, the final simplification is 0.1353. Second, the probability that there is one defective screw, so equal to probability that x is equal to 1, that is e raised to minus 2, 2 raised to x by 2 raised to 1 by 1 factorial, and its final simplification is 0.2706. Third bit, the probability that 2 or more defective screws, that is equal to probability that x is greater than or equal to 2. So this can be obtained using the concept of complement of an event. So which is equal to 1 minus probability that x is less than 2, that is equal to 1 minus probability that x is equal to 0 plus probability that x is equal to 1. From the first two bits, so we substitute probability that x is equal to 0 and probability that x is equal to 1, and it gives us equal to 1 minus the sum of these two probabilities, and finally we get the final probability as 0.5941. Now consider the examples based on geometric distribution. So here for geometric distribution, PMF is P into Q raised to X, mean is Q by P and variance is Q by P square. And let us consider the example. If the probability that an applicant for a driver's license will pass the road test on any given trial is 0.75, what is the probability that an applicant will finally pass the test on the fourth trial? Now for solution, let x denotes number of failures before passing the test. So given P is equal to 0.75, therefore Q equal to 1 minus P, that is equal to 1 minus 0.75 equal to 0.25, and X follows geometric 0.75, and therefore its PMF is going to be 0.75 into 0.25 raised to X for X is equal to 0.12. Therefore the probability that an applicant will finally pass the test on fourth trial equal to probability that first three times failure and at the fourth time, that is fourth attempt, success. So that is equal to probability that x is equal to 3, and by substituting x is equal to 3 in above PMF, it gives us 0.075 into 0.25 raised to 3, and final simplification is 0.01178. Now next example is a person fires shots at a target until he hits the target. The probability that a shot hits the target is in an attempt is 0.8. Assuming independence of attempts, find the probability that he hits the target first beat on the third attempt and second beat on or before fifth attempt. Now for solution, let x denotes number of failures before first success. Given p equal to 0.8, therefore q is equal to 0.2, and x follows geometric with 0.8. So here PMF becomes 0.8 into 0.2 raised to x, and for the first bit, probability that the target will be hit on third attempt, that is equal to probability that first two times failure and at the third attempt success, that is probability that x is equal to 2, and by substituting x is equal to 2 in above PMF, it gives us finally the probability equal to 0.032. For second bit, the probability that target will be hit on or before fifth attempt, that is equal to probability that x is less than or equal to 4, that is equal to probability that he will hit the target at the first attempt, or that means plus probability that he will hit the target at second attempt plus probability that he will hit the target at third attempt plus probability that he will hit the target at fourth attempt plus probability that he will hit the target at fifth attempt. So that is equal to sum of the probabilities. So by substituting x is equal to 0, 1, 2, 3 and 4 in above PMF, see, and simplifying, the final simplification is 0.99968. So that means probability that target will be hit on or before fifth attempt is nearly equal to 1. Now consider the examples based on negative binomial distribution. So this one is the PMF of negative binomial distribution with parameters k and p. Mean is here k into q divided by p, and variance is k into q divided by p square. Here also mean is less than variance, In other words, variance is greater than mean. Here the example is, if the probability of having a male child is 0.4, find the probability that the fifth child is the third son of a couple. So for solution, let x denotes number of female children before kth male child. So given p is equal to zero point 0.4, therefore q is equal to 1 minus p, that is 0.6. K equal to number of successes, k is equal to 3, and number of trials, x plus k equal to 5. Therefore x is equal to 5 minus k, that is 5 minus 3 is equal to 2. Here x follows negative binomial distribution with parameters 3 and zero point 0.4, whose EMAP is like this, and therefore probability that the fifth child is the third son, that is exactly equal to probability that x is equal to 2 in the NBD distribution, and substituting the values, x is equal to 2, p is equal to zero point 0.4, q is equal to 0.6, and x plus k equal to 5, and by simplifying this equation, finally it gives us the final probability 0.13824. Next example, a student has taken 4 answer multiple choice examination orally. He continues to answer the questions until he gets 2 correct answers. What is the probability that he gets them on the 8th question if he guesses at each answer? So for solution, let x denotes number of wrong answers before he gets second correct answer. So given p is equal to 1 by 4. So as the question is multiple choice question out of 4, the probability is 1 by 4, that is 0.25. Therefore q is equal to 1 minus p is 0.75. Number of correct answers, k is equal to 2. Total number of atoms, x plus k is equal to 8. And the x is equal to 8 minus k, that is 8 minus 2 is equal to 6. And here x follows negative binomial distribution with parameters 2 and 0.25. Therefore the probability that the student gets second correct answer on 8th question equal to probability that he gets 6 wrong answers and 1 correct answer in first 7 questions and second correct answer on the 8th question. So that means equal to probability that x is equal to 6, and by substituting x is equal to 6 in above equation, p is equal to 0.25 and q is equal to 0.75. The equation for probability becomes 8 minus 1 c 2 minus 1, 0.25 raised to 2, 0.75 raised to 6, and after simplification it gives final probability 0.07786. Thank you. Thank you very much.